Water faucets date back to at least 1700 BC. Archaeologists discovered that the Minoan palace in Knossos on the Greek island of Crete had a plumbing system consisting of terracotta pipes, providing water to faucets made of gold and silver. Today's water faucets are typically made of cast brass plated with another type of metal. This single-handle faucet is most commonly seen in a bathroom and is chrome-plated. This factory uses steel molds to produce sand molds for casting the brass components. The sand mold is actually a sand model of the brass part, only slightly smaller. Workers file off the excess sand, which hardened inside the channels, consuming the entirety of the steel mold cavity. In the casting area, technicians load brass ingots into the furnace, which stands next to an automated casting machine. The furnace heats the solid metal at a temperature of nearly 2,000 degrees Fahrenheit, causing the metal to melt. Technicians place the sand mold inside a two-part steel mold. The inner cavity is in the shape of the faucet part, only slightly larger. The molten brass will flow into the gap between the sand mold and the steel mold cavity. The casting machine positions the mold over the furnace and lowers the mold into a tube, which injects molten brass into the cavity. 20 seconds later, the steel mold opens, and technicians extract the castings and set them aside to cool. Then, the parts are placed into a shot blasting machine which removes all the sand. Next, a worker saws off the excess brass that solidified in the channels of the steel mold. This separates two faucet bodies that were cast together. At the next station, a press forces the part into another machine, trimming off seams and jagged edges. Each faucet body is placed on 3 consecutive computer-guided machines. One machine cuts threads in the spout hole for the screw-in aerator. The other cuts threads in the hole on top for the screw-in cap that retains the cartridge. The third cuts threads in the installation hole on the bottom. A robotic machine polishes the entire surface of the part against 3 separate sanding belts. The first belt is a coarse grit, the second a medium grit, the third a fine grit. This preps the brass for plating. These large automated electroplating tanks coat the parts with 2 layers of nickel, then a layer of chrome. In the assembly area, engineers press a nylon and ceramic disc through the top hole of the faucet body. The disc has brass threads for the screw-in hot and cold water hoses. They attach an anti-leak seal on the bottom and screw the aerator into the threaded spout hole. The aerator separates the water flow into tiny streams mixed with air, reducing the flow, which prevents splashing. They insert a nylon ceramic cartridge in the top hole, securing it with a retaining cap, hidden by a chrome ring. The cartridge is the valve which opens and closes the faucet and mixes the hot and cold water. They thread the screw for installing the faucet on the sink. Then they screw the rubber and steel water hoses into the brass threads of the disc. The factory runs every single faucet it produces through a water test. Engineers manipulate the still exposed cartridge to check all functions, turn on, hot-cold water mixing, and shut off. If the faucet passes inspection, they attach the handle with a small screw. They hide the screw with a cover. Then apply a sticker reminding the consumer to periodically clean the aerator. They package the faucet with a pop-up drain stopper and a P-trap set. The PVC piping retains a small amount of water as a barrier.